Thomson's apparatus. Again, it's a historical experiment, and it demonstrates the interaction between electric and magnetic fields, or electricity and magnetic fields. It also shows the particle nature of electrons. So the first thing we need to do is actually get a stream of electrons. We'll start by turning on over here, which creates, you can see the filament glowing in there, a bright light. Then we need to put some voltage between here and to accelerate the electrons across. So I'll bring it up to about 4,000 volts. And you should be able to see a blue line across the screen. Now that doesn't mean that electrons are blue. What it means is that the electrons are hitting the screen, the atoms in the screen are getting excited, and as they drop back down they give out blue light. So what we've done is we have a hot wire inside the, where the cathode is. That boils electrons off. The electrons are accelerated by the anode at the front, which has got a hole in it, and then they can stream out through the hole across the screen. Now, if we put a magnetic field on these, either side of these electrons by turning on over here and increasing the voltage, we can see as we increase the voltage, the electron beam curves upwards. This voltage is being supplied to the coils of wire, these Helmholtz coils. And as the electrons run around the coils of wire, they create a magnetic field which goes out and around and through. Changed over the direction of motion of our current in the copper wires. Then if we go back over here, you can see that the effect on the electrons is to make them curve downwards. So now we've got the field going in the opposite direction through the Helmholtz coils. We can counteract this magnetic field with an electrostatic field that we're placing between the plates at the top and the bottom of the screen. So to do that, I'll just turn things down again because you really shouldn't sort of make too sudden a change. And all I'll do is I'll just swap over one lead so that I'm now putting an electrostatic field between the two plates. We'll turn it back up again. And where we had a curve before, you can now see that we've sort of straightened out the field. So the electrostatic plate is pulling upwards. Let me turn down the Helmholtz coils over here. Let me turn down the effect of the magnetic field so that it goes off. So the magnetic field is now off. And the effect of the electrostatic field, the plate at the top of the screen, is pulling the electrons upwards. If I put the magnetic field back on, you can see that it's pulling the beam back down again. And when we've got it just about straight, we have the balance between the electric field and the magnetic field. And by working with the two equations, the forces of both equations, we can work out the charge to mass ratio of an electron, thereby demonstrating that electrons are actually particles.